Hello everyone, I'm Amodini, a student at IIIT Sri City. I'm pursuing my BTech in computer science and today I'll be covering PYQs on the topic waves. Okay, so let's move on to our first question. The first question is, a tuning fork with frequency 800 Hz produces a resonance in a resonance column tube with upper end open and lower end closed by water surface. Successive resonance are observed at lengths 9.75 cm, 31.25 cm, and 52.75 cm. The speed of the sound in air is. So, firstly, they have given us the lengths. Right. So, and we have been given that it produces 800 hertz of frequency. Right, this is the resonance that is produced in the resonance column tube, and what they have told us, this is, let's say this is the column, then the upper end is open and the lower end is closed. So it is closed over here. Okay, that's what they have told, and they have given us successive lengths. Okay, so let's take L1 to be 9.75 centimeter, L2 to be 31.25 centimeter, and L3 to be 52.75 centimeter. So we know that this is the end correction. So I'll take it to be E, okay? So we can write it as lambda by 4 plus E is equal to 9.75. Yes, this is the first equation that we can write. And similarly, I can write 3 lambda by 4. 3 lambda by 4 plus E again. There is again this blockage, right? That is equal to 31.25. So what I'll do is, these are my two equations. I will subtract these two equations so that we can remove this E, okay? So that we can cancel this E and we will get our lambda value. Okay, so here we see that we are subtracting it. So you'll get it as 2 lambda by 4 is equal to 31.25 minus 9.75. And from here, you'll get lambda to be 43 centimeter. But we do not want the lambda. We want the sound, the speed of sound in air. So for that, what we'll do is, we'll calculate it using the formula. So I can write it as lambda into frequency, right? If it was time, then I would be dividing lambda by time, but it is frequency, right? And we have been given that lambda will be equal to, speed of sound will be equal to 34400 into 10 to the power minus 2. I can further write it as 344 meter per second. This was in centimeters, so I wrote it as 43 into 10 to the power minus 2 meter. Okay? And we knew that the frequency was 800. So multiplying these two, I got this answer. So with this, we got 344 meter per second, and that is our option D. Moving on to the next question. The fundamental frequency in an open organ pipe is equal to the third harmonic of a closed organ pipe. If the length of the closed organ pipe is 20 centimeter, the length of the open organ pipe is what? So we know that for a closed organ pipe, so this is wherein we'll be using harmonics. Right? So we'll first take the case of a closed organ pipe. Okay, So here we can tell that the third harmonic equal to, I can write this as 2n minus 1 into v by 4l, right? Where n is equal to 2, right? So I'll write it as 4 minus 1 into v by 4l again. So that will be equal to 3v by 4l. And similarly for open organ pipe, okay, let's talk about the open organ pipe. They have told that the fundamental frequency, so the first frequency, then for fundamental frequency, the formula is nv by 2l. So therefore n is equal to 1, right? So v by, here it is 2l dash because we need to find the length, 2l dash. So therefore what we will do now is equate this one with this, because they have told that it is equal, right? And therefore we'll get it as 3l, 3v by 4l, three v by 4l is equal to v by 2l dash. Okay, so I can write this further as, cancelling this, you'll get 3 and then v also gets cancelled. So you'll get it as 3l dash by 2l is equal to 1. And I can further write this as L dash is equal to 2L by 3. And we know that L is in centimeter and that is 20. So 2 into 20 by 3. And that gives me 13.33 centimeter. Remember that this is in centimeter, okay? And that gives us option A. Okay, moving on to the next question. A wave traveling in the positive x direction, having displacement along y direction as 1 meter, wavelength 2 pi meter, and frequency 1 by pi hertz is represented by. So basically, they have given us parameters and we need to find the wave equation. So we need to find the wave equation. Okay. So how do we do that? We know that y is equal to a sine kx minus omega t, right? This is the general formula. So we know that omega is nothing but the angular frequency and that is equal to 2 pi f, right? And we have been given f is what? 1 by pi hertz. So I'll write it as 2 pi into 1 by pi and that gives me 2, right? So therefore we got our omega. Let's move on to the next parameter, k. K I can write as 2 pi by lambda. Yes. And we have been given that our wavelength is 2 pi meter over here. So I can write it as 2 pi by 2 pi and that gives me 1. Right. And amplitude. Amplitude is nothing but the displacement along the y direction. Right. What is exactly an amplitude? So if I draw a wave like this, then this is my amplitude. And they have told it in a different way. That is it is having a displacement along y direction. So this is the displacement along y direction. Okay, and that is 1 meter. So therefore our A is also 1. So therefore I can write this as y is equal to 1 into sine k. K is again 1. So x minus omega is t. So x minus 2t. So y is equal to x minus 2t, and that is sine x minus 2t, and that is our option D. Okay, so we got our answer. Moving on to the next question. A point source emits equally in all directions in a non-absorbing medium. 2 points P and Q are at distances 2 meter and 3 meter respectively from the source. The ratio of the intensities of the waves at P and Q is. Okay, so first of all, what is something that we need to focus on is that they are in a non-absorbing medium. Non-absorbing medium. Right. So there are 2 points, okay? So let's just say there is this source, and there is a point P, and there is a point Q. And P is at a distance of 2 meter, and Q is at a distance of 3 meter. The ratio of the intensities of the waves at P and Q is, okay? So we know that when it comes to intensity, okay, when we talk about intensity, it is nothing but energy per second per unit area. Per unit area. So I can say that my area is proportional to r square. Right? I can further write this as my intensity, that is I, is inversely proportional to r square, right? Because it is inversely proportional to area, and therefore it is inversely proportional to r square. So I can further write this as I1 by I2 is equal to, it will be inverse, right? So R2 square by R1 square, and that will be 3 square by 2 square, and that will be 9 by 4. So it is 9:4, and that will be our option C. Okay, moving on to the next question. In a sinusoidal wave, the time required for a particular point to move from maximum displacement to zero displacement is 0.170 second. The frequency of the wave is what? So here we've been given the time, okay? The time required for a particular point to move from maximum displacement. So there was a maximum displacement and then it moved to zero displacement. Okay, so what we can say is that time period is always equal to T by 4. Yes. So I can tell that my time period T will be equal to 4 into the time that I got. So that will be 0.17. And therefore, I can tell that my frequency is nothing but 1 by T, right? 1 by time period. 1 by T. So that will be 1 by 4 into 0.17. And that gives me approximately 1.47 hertz. And that will be my option A, right? Okay, moving on to the next question. The speed of a wave in a medium is 960 meter per second. If 3600 waves are passing through a point in the medium in 1 minute, then the wavelength of the wave is what? Okay. So first of all, we'll jot down what are the things that are given to us. So firstly, they are given us the speed of the wave, and that is 960 meter per second. And they have given us that there are 3600 waves. So the number of waves basically. So from the number of waves, I can tell that frequency of a wave will be equal to the number of waves per minute. And to bring it down to rev per second, I can write this as 3600 by 60. Because it is 1 minute, I can write it as 60 seconds. So that will give me again 60. So that will give me 60 rev per second, right? And similarly, so I got my speed and I got my frequency, and so I can easily find out my wavelength. And wavelength is nothing but lambda, and that is speed by frequency, and that will be 960 by 60, and that is nothing but 16 meter, and that is my option C. Okay, yeah. Moving on to the next question. The equation of a traveling wave is y is equal to 60 cos 180 t minus 6x, where y is in microns, t is in second, and x is in meters. The ratio of maximum particle velocity to a velocity of wave propagation is. So they have given us the wave equation. Okay, so this is the wave equation. Okay, so from here we'll deduce the quantities. So we know that omega is equal to 180 over here, right? This is nothing but omega t, and this is kx, right? So omega is equal to 180, and I can write omega to be nothing but 2 pi by f, right? Similarly, k is equal to minus 6, okay? But then right now you can just write it as 6. So I can further write this as 2 pi by lambda. So from here, I'll get my lambda to be 6 by 2 pi, that is nothing but 3 pi, okay? And I can write my wave velocity. I'll write this as V, okay? Is equal to omega by K, right? So that will give me 2 pi by T into lambda by 2 pi, right? I just substituted the formulas. So here we know this is 180 and this is 6. So I'll get this as, I'll just cancel this out. That is nothing but 30 meter per second. Okay. So I can also write that differentiating this with respect to time. Okay. I'll get this as Vp, that is particle velocity. That will be equal to dy by dt, right? So I'm differentiating this wave equation, okay? So this is nothing but dy by dt, and that will give me my particle velocity, and that will be equal to minus 60 into 180 sine 180t minus 6x, okay? So I can write when is it usually maximum? Vp max will be nothing but when this is 1. So I'll write it as 60 into 180 mu meter per second, because it is given that it is in microns, right? So that gives me 0.0108 meter per second. So we are supposed to find VP max by V, right? So VP max by V is nothing but 3.6 into 10 to the power minus 4, right? So that will be my option B. So we just had to find the ratio of maximum particle velocity. And how do we find a particle velocity? We find it by differentiating the wave equation. And it is maximum whenever sign value is equal to 1. So this part is equal to 1, and that is when it is 90 degrees, right? So with this, let's move on to the next question. Two sound waves having a phase difference of 60 degree have path difference of. Okay, so we have been given that phase difference equal to 60 degree, and that is nothing but pi by 3. And path differences lambda by 2 pi into phase difference. So I can write that as lambda by 2 pi into my phase difference is nothing but pi by 3. And that will be lambda by 6. And that is my option D. Yeah? Okay. Moving on to the next question. Again, we've been given here two wave equations and we are supposed to find the phase difference. Two waves are represented by the equations y1 is equal to a sine omega t plus kx plus 0.57 meter and y2 is equal to a cos omega t plus kx meter, where x is in meter and t is in second. The phase difference between them is. Okay, so this one I'll be approaching it like, so this is my y1 and this is my y2. Here we know that phi 1 is nothing but 0.57, right? Here it is direct. But here for y2, I can write this as a cos omega t plus kx meter. I can write this as a sine pi by 2 plus omega t plus kx, right? So therefore my phi 2 over here is nothing but pi by 2. And phase difference, that is delta phi, is what? Phi 2 minus phi 1. Phi 2 minus phi 1. And that will be pi by 2 minus 0.57. And that will be equal to 1.57 minus 0.57. And that is equal to 1 radian. And that is my option A. Yes? Okay, let's move on to the next question. So the next question is, what is the effect of humidity on sound waves when humidity increases? Okay, so we're talking about the effect of humidity. Humidity is what? Basically the moisture content. Okay, so when humidity increases, what happens? So they're telling the options are speed of sound waves is more, speed of sound waves is less, it remains the same, or it becomes zero. So we know that velocity of sound is basically root of gamma RT by M. Okay, so basically when water vapor, humidity is what? Water vapor is present in the air, right? It is nothing but water vapor, Okay, so we got that whenever the average molecular weight decreases, therefore the velocity
Only
increases and
voice. अब only voice गड़बड़ आ रही है आपकी.
okay, sir. Can you hear me now, sir?
पहले आप voice clear करो. Problem आ रहा है voice में.
Okay, sir. Just a moment. Hello, sir.
Now you can start, please.
Okay, sir. Okay, so we got to know that whenever the molecular weight decreases, our velocity increases, right? So with that, we can conclude that the speed of sound waves is more. Okay? Okay. So moving on to the next question. The next question says that the equation of a sound wave is given as y is equal to 0.0015 sine of 62.4x plus 316t. The wavelength of the wave is. Okay, so we've been given the equation and we know that our omega is equal to 316 right over here, and this is k. And I can write k as 62.4. So I can also write k to be 2 pi by lambda. And similarly, I'll just find out the value. So from here, I'll get that my lambda is nothing but 0.1 unit. And that is my option D. So if you have observed, all our wave questions somewhere revolve around the wave equation. So in this wave equations, what are the few things that we need to remember? The relation between omega and time period of frequency, and the relation between of k and lambda. Okay. Moving on to the next question. From a wave equation, y is equal to 0.5 sine 2 pi by 3.2, 64t minus x, the frequency of the wave is. So again, this is my equation, that is y is equal to 0.5 sine. I'll take that inside. I can also write this as 2 pi by lambda into Vt minus x, right? So here I can write that this is my V and this is x and this is my lambda. So therefore, I can say that lambda is equal to 3.2, velocity is equal to 64, and we need to find the frequency. And from these two, we can find the frequency using the formula. So I can tell that my F is equal with a velocity of 20 meter per second. So the velocity is 20 meter per second and frequency is equal to n. The distance between the consecutive nodes is. So we need to find the distance between the consecutive nodes or successive nodes basically. So we know that that is equal to lambda by 2, and I can write that as v by 2n, and that is nothing but v is over here 20 meter per second and 2n, and that will be 10 by n. And with this we got our answer. So the distance would be 10 by n. That is our option B. Okay, moving on to the next question. The speed of a wave in a medium is 760 meter per second. If 3600 waves are passing through a point in the medium in 2 minutes, then their wavelength is. Okay, this is somewhat similar to one of the questions that we came across before. So again, we have been given the speed or the velocity is equal to 760 meter per second, right? And I can write, they have told that there are 3600 waves passing in 2 minutes. Okay, so I can write that part as 2 minutes is nothing but 120 seconds. And from here, I can calculate my frequency, and that will be 3600 divided by 120, and that will give me 30 waves per second, right? So here we got our frequency, we know the velocity, so we'll directly apply the formula, and that is nothing but lambda is equal to V by N, and that is 760 by 30, and that is nothing but 25.3 meter. And that is my option B. Yes? Let's move on to the next question. A hospital uses an ultrasonic scanner to locate tumors in a tissue. The operating frequency of this scanner is 4.2 megahertz. The speed of sound in a tissue is 1.7 kilometer per second. The wavelength of the sound in tissue is close to. Okay, so first of all, they have told us that the frequency of the scanner, I can write this to be N is equal to 4.2 megahertz. Mega is nothing but 10 to the power 6 hertz. Okay. And then next they have given us that the speed of the sound. Okay. So the speed of the sound in the tissue, that is nothing but V is equal to 1.7 kilometer per second. Kilometer, I can write it as 10 to the power 3 meter per second. So we need to find the wavelength. So again, direct formula, lambda is equal to V by N, and that is nothing but 1.7 into 10 to the power 3 by 4.2 into 10 to the power 6. And that gives me 4 into 10 to the power minus 4 meter. And that is my option A. Here again, one mistake that people could do is converting the units to be wrong, because you can see that there are options wherein it is 10 to the power minus 4 and 10 to the power minus 3. So there could be, like, if you just look at it, there is a chance that we would tell that this would be 10 to the power minus 3 by disregarding the fact that it is actually 1 by 4, 1 by 8, sorry. So that therefore we have to keep in mind that units are extremely important while solving MCQs. Okay, moving on to the next question. So the next question is, a standing wave is represented by y is equal to a sine 100t cos 0.01x, where y and a are in millimeter and t is in seconds and x is in meter. The velocity of the wave is, okay, so we have been given that y is equal to a sine 100t and cos 0.01x. Okay, so I can write this as nothing but a sine omega t and cos k x, right? So I can further write that the velocity, that is nothing but c, will be nothing but omega by k, right? So that will be omega is 100 and this is 0.01. So 100 by 0.01 will give me 100 into 10 to, here this is 10 to the power minus 2. So it will become, if you 10 to the power 2. So it will be 1 into 10 to the power 4. There will be 10 to the power 4 meter per second. And that is my option A. Okay, moving on to the next question. Which of the following equations represent a wave? So the first is a sine omega t, y is equal to a cos omega x, sorry, kx, and y is equal to sine at minus bx plus c, and then we also have y is equal to a omega t minus kx. So firstly, D will not be our option. So this is not correct. And secondly, I cannot write omega t or cos omega x without having both omega and t. So therefore, this and this I ruled out, and C is my option. Though they have changed A and this to be B, but the essence remains the same, right? Y is equal to A sine omega t minus kx plus phi. So this is the essence that remains. Omega has been turned to A, this has been turned to B, and this has been turned to C. Okay, so therefore we cannot singly have just omega t and cos like omega kx. So we have to have those parameters to have represent a wave, and therefore that option C is our correct answer. So wrapping up this session, what did we learn today? We learned about how to deduce the frequency and the wavelength when it comes to wave equations. So firstly, we need to remember the wave equations and the parameters, how they correspond to each other, right? So like I've written, the wave equation is y is equal to a sine omega t minus kx plus phi. Phi is nothing but the phase difference. So there were questions wherein we came across phase difference and we calculated the path difference. There were questions where we calculated the frequency, and there were questions wherein we calculated the frequency using the number of waves per second. And there were also questions wherein we actually deduced the phase difference by, wherein they were questions like it is in cos omega, but then we had to turn it into sine so that we get the phase difference to be pi by 2. And also there were concepts wherein we used harmonics, basically organ pipe, closed organ pipe, open organ pipe, resonance, wherein it was just direct formula application, right? So there were those, and then we are supposed to also remember the root gamma RT by M, wherein we got to know that whenever the molecular weight decreases, the velocity increases. So therefore, with increase in humidity, there was increase in velocity of sound. There were also questions wherein we actually came across the phase difference again. And we also came across the propagation velocity, wherein we found out the maximum particle velocity, and then we found out the ratio between the maximum particle velocity and the velocity of wave propagation. So, how did we find the maximum particle velocity? Is we differentiated this wave equation. We differentiated it. And then we found out the maximum velocity. And then we also had a question wherein we had to equate the intensities, right? And we found out that intensity is inversely proportional to R square. And finally, and one of those few most important questions were the organ pipes one. So in that, we knew that whenever there is a third harmonic, so we'll use 2n minus 1 V by 4L. And whenever there was fundamental frequency or for an open, it is NV by 2L. So there are a few things that you have to remember, few formulas that you have to go through. So what you could do is go back and try these questions on your own, solve it, and whenever you come across questions like resonance tubes or organ pipes questions, go back and revise the formulae. Make sure that you can solve the questions within a few seconds itself, because these questions are something where you can actually grab the marks totally. So with this, we'll be covering all the topics till now. And also, one thing that you have to remember is you can actually try figuring out in how many ways can you actually represent the wave equation. So by twist and turns, by converting it into cos, by converting into sine cos, you can find out how many different ways we can represent the wave equation, so that whenever you come across such questions, you can just solve it in within 10 seconds. And also, the one of the pro tip that I always give you guys, that is always check for the units. There are many students who miss, and then they just end up getting a negative marking rather than actually hanging on to an easy question. So therefore, I want you to focus whenever you're solving the questions. Keep in mind that there would be different units, and then at times you'll have to check the options too. So lastly, I would like to say that practice, practice, practice. Okay, so go ahead, practice, and then if there is a new concept, make sure that you solve at least 20 questions on that topic and then again approach it. Okay, so with this, I'll be wrapping up my session. Thank you so much for today.